May I also introduce now our second speaker, who is Mr. Anton Huber, who has had a long career already in Siemens. But let me mention that since January 2008, Mr. Huber has been the president and CEO of the Industry Automation Division of Siemens, which is an 8 billion euro organization employing 42,000 people worldwide. Mr. Huber's presentation will illustrate the challenges and outline possible solutions on automation in the context of Industry 4.0. Mr. Huber, the floor is yours.
Thank you very much. Good afternoon, ladies and gentlemen. We did hear very interesting presentations the last 2 days about technologies will make a big difference in manufacturing in the future and have a big impact. I would like to talk to you a little bit more about the holistic view in manufacturing. What does it all mean together? And particularly, what does a manufacturer decide today and tomorrow how to survive? I mean, it's important that we know what is going on in research and what technologies are available, but what do we do with our assets? How do we upgrade them? In what direction? This is what I'd like to talk to you tonight. Talking about my perspective, I'm coming from a huge organization. We run around 290 plants worldwide. I'm personally responsible for around 45 plants. So we know what manufacturing is, and we also know the pain of manufacturers, particularly the pressure we get from the market, the competitive pressure. Siemens is a market leader in industrial automation, so we see a lot of plants around the world, see their development, and see where our customers are tending toward, what they invest in, what they believe will survive, and how they will survive with this technology. And Siemens is one of the biggest industrial software companies. We equip around 77,000 customers with software which they use to design products. And you know, good manufacturing starts with a well-designed product. So design for manufacturing is a very important key capability in the future for manufacturers. We are all together in a very interesting business because we did hear already several times today that 7 billion people want to be fed, want to be dressed, want to drive, need products. And vast volumes of resources are used. And only by automation it is possible, to provide this to mankind. And so far, our business is growing as the standard of living is growing and as the population is growing. Now, altogether, we did hear this, internet technologies with all its advantages and disadvantages is driving our business heavily, and it's driving us as manufacturers heavily. It started actually with the B2C, when the customer, when a manufacturer gets direct access to its end customers and can communicate with this end customer, it accelerates the process of providing the products incredibly. And it has major implications in the value add structure of an industrial enterprise. This pressure started with B2C, went down to B2B, to the businesses communicating with each other, went down in the meantime to the machines and IoT. So we see this machine communication provided by internet or enabled by internet infrastructure is a major move. Particularly we see it in the United States, but of course also in Europe. And the reaction in Europe is this Industry 4.0, which more or less deals with the impact of the internet technology on the plant floor, on the manufacturing. This is how we see it. This is how we define who is doing what in the context of the internet. Now, we believe that one of the major let me say, impact or pressure we get from the internet is this acceleration to time to market, and of course also the customized products. But accelerating the time to market is something what we really have, to work on, and a lot of our customers struggle to keep up with this pace. I mean, the other drivers have already been talked about it today. I don't really need to go into this in more details. I know it's easy to read them too. The consequence of all these drivers is complexity in our processes. If you look at the manufacturing processes and the different industrial verticals, then you see a huge complexity growing over time by all what we get in from data security, from regulatory requirements, product safety, product quality, of course, customization of mass markets. They drive the technology and processes. How do we deal with this? Well, we believe that in the long run, you can only stay competitive if you optimize your full value add. Yes, you can do it in certain areas, you can make improvements, but on the long run, you have to go after your full value add process, how you define your product, how you ask your customer, how you define your product, how you develop your product, how you produce your product, and how you maintain your product. They all are more and more, let me say, interrelated and depend on each other, and a competitive company in the long run will only survive if they are able to optimize the whole value chain. If you look at this technologies which now are introduced into, let me say, into manufacturing, into actual practice, then we have heard already today about additive manufacturing, which we think will have a major impact, as you also have heard about it. Also, we did hear today about this Safe Human-Robot Cooperation. We have the same opinion that it has major impact in manufacturing. But just to give you an insight on an example how fast this goes, and this is direct machining in mass production. What do I mean by that? You know all smartphones and the housing and so on. And this housing of smartphones is a typical example where you use injection molding, plastic parts, and I know you produce hundreds of thousands of components. And from our point of view, this was the process to optimize for these devices. But it didn't go this way. It went a very surprising way and a very good way for us. It went to mass machining. So the customer buys thousands of machines in order to machine the housing and not do it with tooling and injection molding. Why? The only reason is timing. Time to market. If you go through a tooling process, if you see your competitor coming out with a new product, and generally this happens before Christmas in certain areas, and if you don't have the right design, you're done. Because with a tooling process, you cannot react anymore. With a machine process, you can get a complete new design out within a week, and you can react onto the competition. So this thing has changed basically overnight. It's a good business for us because we supply a lot of machine builder with CNC controllers. I mean, we saw volumes we have never expected. And if you would have asked me 10 years ago or 5 years ago that machining housing for consumer products will be the process to use in the future, I would have lost every bet. Believe me, we did not believe it. So this has a major impact, and you see what time to market means. This is strictly time to market. Nothing else is driving this technology in this direction. Just as one example. Now, of course, if we look what the processes are introduced into manufacturing, to connect all these technologies to create a manufacturing process in a plant also drives an incredible complexity in automation. It's just, if you look at, if we look at one of our products, like a PLC controller, we started with on-board memory in the kilobyte area. Now we are in the megabyte area, and it's growing. So our customers need more and more memory space, which used to be Boolean algebra and a few relays. It is now megabytes of runtime code. And we see this growing day by day. What is our reaction? I mean, we work on engineering systems in order to help our customers to deal with this code volume they're having and they have to maintain over time. And here you see the last generation of engineering system had about 7 million lines, net line of code. The new generation has 55 million net line of codes, which is, for experts, a huge software system to support creating code for automation. So in order to deal with this complexity and, of course, the cost, this is creating a lot of business for us in the future, too. Because we all know when code is growing, the engineering time is growing, which is needed in order to write and test the code. But even in China, people can see the last 5 years, consecutive years, the wage increases or salary increases were around between 15 and 17%. So you see, not only the code is growing dramatically, also the cost of the hourly rates are increasing. So there is a major need for our customers to look for ways to reduce cost. This is where we are investing at Siemens. For example, we built a so-called TIA portal. We have invested around 1.4 billion euro just for this engineering system. One of our major tasks was, of course, to connect the installed base. The legacy components, around 1,400 components, legacy components, had to be connected to the new engineering environment, because otherwise the customer would have to basically reinvent everything in order to have the advantage. So it's just as an example where we invest money, where in the future we have to take a look at in order to create the productivity which we need in order to have efficient plants. Now, but there's another view. With all the technology which is available, the products which are designed and used get more and more complex. Not only the processes, but also the product get more complexes, because generally people use what is available. And it is also driving complexity. And we see 3 major areas where we have to have a closer look. This one is the digitization of the work along the entire value-add processes. All what the customer basically does in order to get from an idea to a physical product. Extended enterprise, the inclusion of the suppliers and their know-how into manufacturing, into an enterprise, is an important part, particularly when you talk about digitization and digitized environment. And of course, autonomous production will be a major part in the future too. Now, if I talk about digitization of all work, what do I mean? Well, we believe that in the long run, all what is basically created physically can be done digitally. So it is about the digital representation of the physical world. I want to design my product, I want to run my product, I want to digitally produce my product, I want to see how this all works and whether it works. And if this is all done, I will go physical. I will invest in my plant, I will invest in my machines, but not before. So, representing the physical world, this is what we think digitally is the major move the manufacturers and creators of physical products will have to do. We call it digital enterprise. Where do we start? I mean, we are often asked, yes, we understand that this is necessary, but where do we start? We have all legacy systems. No one can afford, also not Siemens, that throw all the software out and buy some magic software. We have to live with what we have, our legacy products. But we see that the only way to get this digital world going is to go to a data platform which allows you to share data with all your legacy systems, which is possible, which can be done. If you are able to do this on a global basis with all your manufacturing sites, with all your R&D sites, you can exploit the factor costs around the world. You can exploit the material costs around the world. But only then, only when you have, can synchronize your work of the engineers, of the manufacturing engineers around the world. And this is why we think a starting point is to get your collaborative platform in for managing your technical data. Of course, it is not just the data. If you have your data available and you want to go down the road of simulation, which basically enables a lot of productivity, you have to go to model-based designs. Model-based is the only way where you can go basically easy to simulation of your product and also to simulation of your processes. So when you do this, when you build this backbone where you connect all your resources, your manufacturing and design resources on a global basis, you will find out that you have huge amount of data to handle. I will show you an example in the next slide. So when we talk about big data, this is really big data. Managing all your digital data from your product designs, from your simulation of your products, from your simulation of your manufacturing. And this is why we believe you can never run it on an ERP system, even if there are some dreams today. You need a high performance data backbone in order to handle all the data. And here is an example what a customer of ours started. The idea of this customer was to have the time to market for a camera in order to escape the copycats, because the idea was if the camera is on the market till if someone copies it, it takes some time till this is copied and the tools are done, and then the manufacturer wanted to have its new camera out. So even if you would have copied the camera, it would not make sense, because who buys an old camera? So this was basically objective. And this manufacturer was able, after about 6 years of investment in improving the process, to do exactly that, to reduce time to market by 40%. It is an incredible work because, you have also now, you cannot accept physical prototypes from your suppliers anymore. You have to ask your suppliers to send you digital prototypes, to do your mock-ups with the components of your supplier digitally, to do your simulation digitally. So it changes the whole value add of how you work with your suppliers. And the consequence is, you can see on the right side, the total data set of this camera, including integrated circuit data, the integrated circuits they needed for the camera, was 1.8 terabyte. When the customer was able to do it fully digitally, it was 300 terabyte. So 300 terabyte for one product. And you have to mention that hundreds of engineers have always access to this data on a real-time basis, because this is a huge expert platform where they basically have access to have. It just shows you, the power of this digital technology. And you know, we did it with an airplane turbine manufacturer, went through the same process and connected the PLM process to his manufacturing process in order to help him to improve his manufacturing process and also improve the design of the product. Now, what did we do? So this is obviously the early adopters have this technology already working. And of course, customers look at us and say, Siemens, what are you doing? So we have basically two showcase plants now. One is in Hamburg, Germany, and one is in Chengdu, China, where we show customers what is feasible today. So it's not about waiting till all this nice technology is out there and is coming along with Industry 4.0. If we look at the early adopters, they are, I would say, 3 to 5 years ahead of their competitors. And it's not the time to wait, it's the time to see how you can survive in this kind of environment. And this also kind of brought us to, to connect our companies is actually to build this data backbone is a huge investment for our company. And I do it for my division. We connect have connected over 10,000 engineers in the meantime on a global basis, so we can really do real-time work around the world with the whole engineering community. And we also show this to our customers. So they come to us and they talk to us about the change processes, because it is not a simple process to get an engineer to follow quite different processes in order to enable this collaboration around the world. Well, what I wanted to show you that the full scope and the impact of every technology is having on the full scope. I showed you a few examples, and the message is Industry 4.0 will happen. We will provide the components we can provide. Of course, we do not produce and develop everything. This will be done with a lot of partners around the world. One will be not speaking after me, but what I wanted to convey to you, a lot of this technology is available, what we call 4.0. It has to be applied. And I can tell you, it is quite dangerous what I'm seeing, and one speaker this morning also said, do not believe that, let me say, the industrialized countries will lead this process in getting digital. I can tell you, the countries which are called emerging countries, they will not invest in the old technology. They have no other chance than to invest in the new technology. So, as we saw it in the United States in the 90s, when the transplants came up, they were the most competitive plants in the world building cars. This is what we are seeing coming to. This technology will be much faster absorbed in emerging countries than in the high-tech countries, because we all have to lose. We all, in the industrial countries, we have installations. This is what we try to protect. But this view, in my view, in our view, is wrong. We better watch out. Things are moving much faster than we thought. Thank you very much.
Thank you very much, Mr. Huber. We have, I don't know how to interpret that. We are in Science 2.0 in this moment, but we are already in Industry 4.0. Understand that science started before industry. That's something we have to sort out.